delighted to begin today's first session with Professor Ritula Thakur ma'am. So I now invite ma'am to introduce herself briefly and take us through today's topic.
Thank you. First of all, I would like to thank you to the management of UIT MDU Rohtak for giving me this opportunity to be here among all of you to share a few glimpses of our work done on big data analytics for smart grid. So regarding myself, I'm Dr. Ritula Thakur. I'm working as Associate Professor and Head of Electrical Engineering Department in NITTTR Chandigarh. I'm basically a core electrical person. I've done my master's in power system, but lately, after joining NITTER in 2006, so it's been now 20 years since I'm a part of NITTTR. I've been working in different multidisciplinary areas such as embedded systems, AI, big data analytics, IoT, and I've also done my after completing my PhD, I have worked as visiting scholar in Russell Richard Research Laboratory, Athens in USA, where I worked on developing sensors, low-cost sensors for agriculture and smart farming. So as I said, my area of research is mainly big data analytics, smart grid, and now lately I have also started working on electric vehicles, and I've also developed some MOOCs courses. So 4 MOOCs courses I have developed on the SWAYAM portal. Yeah, so that was about me.
So thank you ma'am. Now you can start your session.
Okay. So can you see my screen? Is my screen visible if someone can tell me?
Yes, ma'am, it's visible.
Yes, ma'am.
So since this program is on artificial intelligence, so machine learning is a very important part of artificial intelligence. And as I said, that in today's multidisciplinary world, we cannot restrict ourselves to a particular branch. So although I'm from electrical department, but today the talk I'm going to cover is the application of machine learning in smart grid. So the title is Big Data Analytics for Smart Grid. I can move my slide. Yeah. So these are the contents I'm going to cover today. Firstly, I will be discussing what are the challenges which are there in today's power system. And then we will see, because the application is in smart grid, a little brief about what smart grid is, what are the various differences between conventional grid and smart grid. So because this must be a mixed audience from different disciplines, I will try to keep it as simple as possible and not go into much technicalities of the smart grid. But I will try to give you an overall idea about so that everyone understand what exactly is smart grid. Because as we will be seeing in the coming slides, smart grid is basically not restricted to one particular discipline, but it is an amalgamation of the various disciplines. After that, we will be seeing what are the various sources of the big data, and then what are the various characteristics of big data. And finally, we'll be discussing some potential applications wherein the big data analytics can be applied in the smart grid. I'm not able to move the slides very freely. I do not know why this is happening. Okay, I have to click here. So the very first question is, what are the challenges which are there in the today's power system and what are the impacts? In order to see that, we have to understand our traditional power system in which there was a centralized electricity generation, right? And that was in a relatively few locations generated by large power plant that can be easily controlled as needed. And in the conventional power system, the energy generally flowed in one direction. So there was a unidirection from the source of the supply to the electricity customers. So as we are shifting from traditional grid to smart grid, earlier the things, as you can see from here, they were quite simple. It was a unidirectional flow of power from centralized power generation to the customers. And however, as we are moving towards better technologies, advanced technologies. Tomorrow is going to be like this, wherein there will be a lot of new things which will be added to the system, which will add to, in fact, the complexity also. So as we are in today's world, we are moving in this evolution of the electricity grid. There are certain challenges which are there. The very first challenge is the integration of the renewable energy sources into the main grid. Now, we all know, whether we are from electrical department branch or not, we all know that lot of focus is these days being given to renewable energy sources. You all, many of you must also be having solar rooftop plants at your homes also, and or in the offices also. So but where is the challenge? We are saying that this is a challenge, integration of the renewable energy sources into the main grid. So can any of the participant tell this? Yes, you can write in the chat box, or else you can just raise your hand. See, let us try to make this session bi-directional, not unidirectional, right? In case it will be a unidirectional, I will also feel bored and maybe I go to sleep and you might also go to sleep. So already it is evening time, I understand, after whole day. So let us keep it bi-directional. So in between, I will be asking you questions, because otherwise I will be just talking to my laptop and I don't feel good about it whenever I do that. So please answer whenever I'm asking you question. My question is that why is the integration of these renewable energy sources like solar, wind into the main grid a challenge? Can someone answer this question?
Yes,
Because other,
ma'am.
yeah,
This is Dr. Pooja from ITS Mohanagar. I think
yes.
maybe one of the biggest challenge of if we talk about the solar panels,
Hmm.
maybe the cost of maintenance, cost of installation, but cost of maintenance maybe it's too much.
Yeah,
Maybe
yes.
it may
Very
be one
right.
of the challenge and
That is one of the
maintaining
reason. You're very
maintenance
right.
also.
Very right. Cost is one of the factor. What
Yes, ma'am.
else?
Maybe the maintenance also, maintenance cost.
Maintenance is also a factor, right?
And maybe
Uh,
the people should be aware of the advantages of these. That awareness is also to be made.
uh-huh. Uh-huh.
Due to
Okay.
more demand of electricity, ma'am.
Okay. Mr. Puneet Chawla is saying due to more demand of electricity. A demand of electricity is one of the challenges. But my question is, how is the integration of renewable energy sources into the main grid a challenge? Okay, maybe you want to say, Mr. Puneet, you want to say that there is more demand, but renewable energy sources are less. Is that what you're trying to imply?
Actually, the integration of renewable energy sources is the main concept which from where it is being found is because the demand is more and the
Mhm.
our conventional resources are not able to meet the demand which is being required. So for that, we need the renewable energy resources for
You are very right
the
in saying that.
demand, and that's
That
why
is, in
integration
fact,
is required.
one of the challenges that. But my question is, how is the integration of renewable energy sources into the main grid a challenge? Of course, we need to go towards renewable energy sources because there is more demand of electricity. But ये renewable energy sources को integrate करना अपने आप में challenge कैसे हो गया? It's good, at least आप लोग respond तो कर रहे हैं. कोई बात नहीं, at least try कीजिए. Any other answers?
Ma'am, reduced inertia.
Right, very good. Who is this?
Ma'am,
May I
Bhavya
know your name?
Chaudhary.
Hmm?
Bhavya Chaudhary.
From which college?
Ma'am, MD Rohtak, student coordinator.
Very nice. That is one of the biggest challenge, I would say, because you see all these renewable energy sources like solar, wind, etc. They have got very less inertia. They've got low inertia. However, our conventional grid or the main grid has got synchronous generators which are of high inertia in nature. So the integration of this low inertia into high inertia main grid, that is one of the challenge. Second challenge is that all these renewable energy sources, they are intermittent in nature, है ना? आज सूरज है, कल पता नहीं होगा कि नहीं होगा. For those who are from northern India, you must have seen the change in the weather in the last few days. We had been literally struggling with the fog and there was no sun for almost a month. and only since last 2-3 days हमारे चंडीगढ़ में तो अभी 2-3 दिन से ही सूरज निकल रहा है. So it is very intermittent. तो उसके मतलब you are not sure about it. So that intermittency of renewable energy sources is again one of the challenge which is there whenever we are talking about integrating these renewable energy sources into the main grid. Okay, Mr. Vivek is asking, please elaborate on the concept of low inertia. Okay, I'll just talk a little about this. You see, what happens is when we are talking about high inertia, for example, you must have seen अच्छा एक और बात मुझे बताओ कि is everyone comfortable with Hindi here, or we have some participants from the south also? Because I have this habit of, switching in Hindi in between. So do we have a mixed participants? Okay, tell me one thing. Have you seen this cycle stand ever? Right, cycle stand. There are, all the cycles, they are stacked with each other. Suppose what happens is that if one of the cycle falls, and in no time, all the cycles, they fall. So that is because of the low inertia of the bicycles. However, high inertia, suppose there is our synchronous generator, which is there in our main grid. It has got high inertia. So suppose sometime if it goes off the balance or it goes out of synchronism, then because of that high inertia, it has the tendency of coming back to the stable system. So that is known as high inertia, whereas all our renewable energy sources like solar, wind, etc., they have got low inertia. So when you are trying to integrate these two systems, then it becomes a problem. I hope that answers your question. Okay, another challenge is that these renewable energy sources are located far away from load centers, again causing problem of losses. Then the conventional energy sources, they are getting retired. Okay, one more thing, when I was talking about integration of renewable energy sources, just to give you some facts about it, there is a report which says that by the year 2040, about 2300 gigawatts of renewable energy sources will be integrated into the main grid. Just a second. Beta, मैं class में हूँ. I'm in the class, okay? I'm in a class right now, I can't talk. So these conventional energy sources are getting retired, as one of the participants, Mr. Puneet Chavla, he was talking about the demand, increasing demand, right? But at the same time, our conventional energy sources, they are getting retired. Again, according to one of the report, by the year 2030, about 750 coal-fired power stations, they will be getting retired, which is again one challenge. Introduction of power electronic converters in the grid. How is this a challenge? How is this a challenge? Introduction of power electronic converters in the grid. What does it cause? Can anyone tell? What do these I think those from electrical or electronics background, they can answer this question. Wherever we have these power electronic converters, means there are switches. So wherever there are switches, high switches, it causes harmonics. So again, harmonics, whenever they are introduced in the system, they cause power quality issues. So it is not only the amount of power which is a problem with us, that the power is less, generation is less, whereas the demand is more. The quality of the power which we are getting is again getting deteriorated because of this introduction of these power electronic converters. And of course, there is an increasing global demand of electricity. There is going to be about 78% increase in the global demand of electricity by the year 2030. Again, visible cause of worry. So just to have a quick recap, let me ask you a question about all the points, from all the points which I just discussed. Can anyone answer, by the year 2040, how much more gigawatt of renewable energy will be integrated into the main grid? Your options are A, 2400 gigawatt, B 2700 gigawatt, C 2300 gigawatt, or D 2500 gigawatt? I think I just mentioned it while I was discussing my various challenges. Yes, can anyone answer?
What?
Anji? Yes, you can
Ma'am,
write it
option B.
also here.
Ma'am, B
Option
option,
B.
I guess. 2700 gigawatt.
Any other?
2700.
So majority are going with 2700 gigawatt. Okay, we are getting one answer 2500 also. दो रह गए उनको भी 2400. एक रह गया जो उसको भी बोल दो. Actually answer वही है. Answer is 2300 gigawatt. So by the year 2040, about 23 gigawatt of renewable energy will be integrated into the main grid. So should I worry about this? Is this a cause of worry? Yes, definitely I should. Why? Because of the impact of these changes which are causing on the grid. Already our existing infrastructure is overstressed, which is causing grid stability issues such as transient stability, voltage stability, thermal limits. Already the transmission lines, they are working on their limit, and this is the present power scenario which anyone can see. It is literally struggling to maintain the frequency and voltage. So as we can see from here, the production is less, whereas the consumption is more. There is more demand of electricity. So what does it lead to? It leads to the blackouts. Does anyone remember this blackout which happened in India on 30th and 31st of July 2012? आप लोगों को याद है? This happened about how many years हो गए अब इसको? About 14 years back. So this was one of the biggest blackout in the history of India, in which about 22 states, 700 million people from 22 states, and mainly the states which were affected were northern region, eastern region, and northeastern region. So 22 states were without electricity for 2 days, and 32 gigawatt of power was taken off grid, causing huge financial losses. And one of the cause of this blackout was the multiple existing outages, high loading on 400 kilovolts Bina Gwalior Agra link. So there is a 400 kilovolt Bina Gwalior Agra link. There was some kind of maintenance work which was going on there, and suddenly this 400 kilovolt Bina Gwalior Agra link, there was some misoperation of its protection system which led to its loss. And then you remember I told you one example of the bicycle stand wherein one cycle falls and in within no time all the cycles fall. So same kind of situation happened in India. And one other reason was that because it was July, and July we know that in northern India it is the most humid season wherein we cannot live without air conditioner. So there was overdrawal of power, mainly by the northern region utilities, especially UP, Uttar Pradesh. So they were overdrawing the power which is allocated to them. So this caused this kind of blackout. So that is why we need to go towards more smart technologies such as smart grid. So smart grid is self-healing. Self-healing in the sense that whenever such kind of fault occurs, the grid should be able to come out of it on its own. What makes it smart basically? So what is a smart grid? Let us first understand that. So a smart grid, there is not one single definition. If you ask a meter engineer, he will say, to me, smart grid is nothing but advanced metering infrastructure. If you ask a protection and control engineer, he will say, for me, the smart grid is a substation and distribution automation. To a control room operator, smart grid is nothing but distribution and outage management. To a design and planning engineer, smart grid is asset and design management. So to an IT engineer, The challenge is to bring it all together. So we can say that, as you must have heard of this story of four blind men and elephant. So everyone is holding different parts of the elephant and they're trying to define it in the similar way. A smart grid is not related to any particular discipline. It is basically a multidisciplinary area with a lot of research scope. So in this, an IT engineer is also involved, an electrical engineer is also involved, an instrumentation and control engineer is also involved, communication engineer is also involved. So a lot of multidisciplines have to come together in order to make a smart grid. So what is it which makes the grid smart? It is basically the digital technology that allows for two-way communication between the utility and the customers, and lots of sensors which are there along the transmission line which make it smart. So according to NIST USA, National Institute of Standards and Technology, a smart grid is a modernized grid that enables bidirectional flow of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. I will explain this definition more in the upcoming animation, wherein we will see the difference between a smart grid and a conventional grid, and then you will come to know basically the main difference. What do I mean by bidirectional flow of energy, two-way communication and control capabilities? So I will try to explain that in that. So this video I can just skip as of now. So these are some of the smart grid goals. It enables customers to reduce the energy use, increase use of renewable energy sources, improve reliability and security, facilitate infrastructure for EVs. In fact, electric vehicles are also a part of smart grid. So if we talk about the infrastructure of smart grid, it is a combination of information infrastructure and electrical infrastructure. So an IT engineer, intranet, when combined with electrical, makes a smart grid infrastructure. And sometimes smart grid को हम energy internet भी बोलते हैं, because हमारा energy और internet intelligence infrastructure का combination है, which is causing the two-way flow of electricity and information. Yeah, this is the animation I was talking about. So let us now try to understand the difference between conventional grid and smart grid from this animation. So in case of a conventional grid, as we discussed earlier, there used to be a centralized generation from which the energy flowed in one directional with the help of transmission lines and transformers from the generation to the consumers. So the flow of energy was mainly unidirectional in nature. However, with the advent of renewable energy sources such as wind, solar, which were installed along the transmission line, and also apart from that, at the rooftop of the consumers, now there was a flow of energy back from the user or consumer back to the grid. So now the consumer becomes the prosumer. There's a new term which was coined, prosumers. So prosumers are nothing but those who produce the electricity, and as well as they are the consumers. So now one of the differences is that earlier there was a unidirectional flow of energy. However, now there is a bidirectional flow of energy. Apart from that, there is a central control station, which is with the help of these smart meters, advanced metering infrastructure, which we call in terms of smart grid. So now these consumers, so these consumers now they are sending the messages, or they are communicating with the main grid back, as well as they are receiving the information from the central control station. So now there are two things. One is that now there is a bidirectional flow of energy as well as two-way communication. So now the consumers, they are not only, earlier they were only at the recipient end, but now they are also sending the information with the help of these smart meters. They are sending the information back to the control station. Now, what is it leading to? Now comes the main crux of our talk today, that is big data. So much of information is being shared through these sensors which are installed along the transmission line, through these smart meters which are installed at the premises of the consumers, which are again communicating. Then apart from this, we also have PMUs, phasor measurement units. There is a weather data, because these renewable energy sources, as we had discussed earlier, they are intermittent in nature, so that is why we have to rely on the weather data also. So a lot of video surveillance data is also being sent in order to predict the generation of solar or wind or other renewable energy sources, short-term load forecasting, now forecasting, etc. So massive amount of data is being generated. So that is why and this data is known as big data analytics. And how to analyze this data is another challenge, and that is another research area also. In case many of the participants here, they are planning to do their PhD in some area, then I can suggest that big data analytics in smart grid is big data analytics in smart grid. It is one of another area wherein the work can be done. And even in our institute also, one of the PhD scholar in computer science department, he is working in this area, big data analytics for smart grid. So that is what I said, this data is complex. That is what we are going to study. The characteristics of this big data we are going to study in the coming slides. So one of the characteristic is that this data is very complex. It is got multidimensional. There is a lot of uncertainty. There is lot of uncertainty in the data. So that is why we require advanced computational, such as optimization algorithms, machine learning, deep learning. All these techniques are required to analyze this data. And there are various applications wherein we can do that. We will see that in the coming slides. So this part I will just skip because it will go into much of the core. Just to give you an idea about NIST Smart Grid Framework, so we have this conventional electricity system of this yellow line, wherein we have bulk generation, transmission, distribution, customers. Apart from that, now they are talking with each other. For example, there's a market, there is operation, there is a service provider, customers, they are also communicating with each other. There are a lot of intelligence sensors which are there, building automation is there, industrial control system is there, electric power metering is there. We are having smart meters, which forms a part of advanced meter infrastructure. So all these are a part of smart grid. So where is this data coming from on which we have to apply the machine learning or the deep learning? What are the various sources of the data? Smart grid sensors, phasor measurement unit, smart solar inverters, the weather data. Vihan, can you talk to your papa? Tell him I'm taking the class. So weather data is there, and then asset health monitoring of the various equipments are there. Intelligent electronic devices are there. Video surveillance is there. Wind energy data, smart meters, etc. All of them are part of this data source. So all of these are part of big data. So there is literally, we can say there is a data explosion nowadays. Every 6 seconds, because if we talk about data, every 60 seconds, about 98,000 plus tweets are being done. 7 lakh status updates are being done on Facebook. 11 million instant messages are being sent. So now we are not talking in terms of megabytes, we are not talking in terms of kilobytes, we are not talking in terms of gigabytes, we are not talking in terms of zettabytes, we are talking in terms of yottabytes. And yottabytes are nothing but 10 raised to power 24. Now coming to the various characteristics of big data. Now let us understand that the data, big data which we are getting in a smart grid, what are the various characteristics of such kind of data? So 4 V's. V's are nothing but the characteristics of big data. These are volume, velocity, variety, and veracity. So we will see each of this characteristic in the coming slide. First is the volume. Volume is, of course, it is a lot of records and required data file storage. So high volumes of data from smart meters and advanced sensor technology leads to huge volume of the data. So this is the amount of volume is nothing but the amount of data that needs to be processed by the big data. From where it is coming, for example, every phasor measurement unit which is installed in the transmission system generates more than 1 gigabyte of data per day. Now imagine, single PMU in one day is generating more than 1 gigabyte of bytes of data. And if we talk about the smart meters, there were about 70 million smart meters which were deployed in USA, generating 96 reads per day, amounting to approximately 67 gigabytes of data in one day. Even in India, if we talk about smart grid, where we have reached that we are at least aiming to install these smart meters everywhere. Already in Chandigarh, they have started replacing the conventional meters with these smart meters. So now you imagine, now when all the meters will be replaced by these smart meters, then what would be the amount of data which will be generated at that time? Apart from these PMUs and smart meters, also intelligence electronic devices, DFR, sequence of event recorder, they also generate enormous amount of data. Video surveillance generates massive volume of data. Video surveillance, weather data, they are also generating massive amount of data. So coming to the second characteristics, that is nothing but velocity. So what is velocity? Velocity refers to the speed requirement for collecting, processing, and using the data. So it is not only the amount of data which is being generated, it is also how fast this data is being generated. So if we talk about PMUs, phasor measurement unit, in 1 second, it is generating data at the rate of 60 samples. Now, if we compare this PMU with the RTUs which were there in our conventional SCADA system, in 4 to 6 seconds, they were generating 1 sample. As compared to that, the PMU is generating 60 samples in 1 second. So now can you see the difference in the rate at which the data is being generated? It is huge, huge difference. So the third type of characteristics of this data which is generated is the variety. What do you mean by variety? Variety means because earlier in our conventional grid, there was only one type of data, right? हमारे पास क्या होता था? Voltage है, frequency है, और ज़्यादा से ज़्यादा हमारे पास rate of change of frequency आ जाती थी. So it was a, single type of data was there. There was no variety in that. But now, because we are getting heterogeneous big data sets from diverse sources, and of course, these are in different formats, they are multidimensional field. So that is why now we have structured data, semi-structured data, unstructured data. So that is why we have a lot of variety. For example, the relational data or our electrical parameters, they come under structured. Web services, they come under semi-structured. Video data or the weather data, that comes under unstructured data. So now again, we have to deal with heterogeneous set which is coming from diverse sources, and of course, they are multidimensional in nature. The format is also different. Weather forecasting, maps, drawings, pictures. Structured data is combined with unstructured data to produce meaningful insights. And the last characteristic of this big data is nothing but the veracity. Veracity means how reliable the data is and what is the quality of that data. How reliable the data is, in the sense that when we are getting such a huge volume of the data at such a fast rate, velocity, variety, we are getting multidimensional data, we are getting multiple sources, we have got variety of the data, then again the question comes, how much reliable this data is? Because from this data only, when you will be applying the machine learning and deep learning algorithms on this data, you will be uh, getting meaningful results from that. But if the data itself is not reliable, then how do we ensure the safe system operation and stability of the system? That is again one question. So veracity means that how reliable the data is, uncertainty of the data. So the trust and data quality of the collected data for big data management system refers to the veracity. The PMU data, as we have seen, every second it is generating 60 samples. So there might be some missing PMU, missing electric usage, poor quality needs to be combined with the grid data. Again, that is one of the challenge. Now coming to the another portion of our talk, that is the potential applications of big data analytics in smart grid. Now, before I come to the potential applications, are there any questions from the participants? From whatever we have discussed till now, are there any questions from you? Or any doubts? Or anything you want to discuss?
Excuse me, ma'am.
Yes.
Ma'am, my question is that if we talk about the data in grid, smart grid,
Hmm.
so is there unstructured data also?
Yeah. As I said that, you have this data because now we have renewable energy sources. When you have solar, then of course you need weather data. You need to rely on the weather data to predict what will be the sun, whether there will be sun tomorrow or not, whether there will be wind or not, for in order for the wind turbine to turn. And that weather data is nothing but the images and the videos. So all those data, they are unstructured in nature.
Okay, ma'am. Thank you.
Yeah. Anything else?
Ma'am, what about the security of that data which we are capturing?
That's a very good question. Very valid question, I would say. In fact, that is also another one of the challenges which are there. So cyber security in smart grid, that is another area wherein we need to work upon. And that is, in fact, need of the hour. I was to discuss this point later on at the end of the session, but good thing that you raised this question here, because these days when the wars are happening, na, it is not only happening at the battlefield. Now the battle is at the data level also, and you must have. I don't know how many of you are aware that there was a big यूक्रेन में एक बहुत बड़ा blackout हुआ था यूक्रेन के ग्रिड में, and it was said that it was not malfunctioning of the grid, it was actually an attack on Ukraine. So similar kind of thing happened in Bombay also, although it is not verified whether it is true or not. But again, it is being said that that blackout which happened in Bombay was actually an attack on the grid. So as we are going towards these technologies, smart technologies, wherein we have to depend upon this huge big data, the reliability, as ma'am has very rightly said, that how secure that data is, it is very important. So cyber security in smart grid, this is another important area wherein you can work upon. And in fact, if you will do some literature search, you will get many good publications. So people have already started working in this area. They are already working in this area, cyber security in smart grid.
Okay, ma'am. Thank you. Actually, it is really the area of research, and it is again the biggest challenge, I think.
Yeah. It
Okay,
is.
thank you.
Yeah. Anything else? Okay. So now let me come back to the last portion, in fact, that is potential applications of big data analytics in smart grid. So the applications of big data analytics are everywhere. If you talk about the market operations, Then energy forecasting, price forecasting, risk analysis, revenue management, these all are covered under market operators. If we talk about transmission operators, then wide area control, state estimation, stability enhancement, real-time monitoring, congestion management, visualization, all these topics are potential applications in transmission. If we talk about generation, then the planning of generation, economic load dispatch, you can apply the big data analytics in this area. Aggregators or other businesses, again, risk analysis, forecasting, distribution side also, and end user side also. So end user side, in fact, one of the application which I'm going to discuss in the coming slides is this at the end users only, that how to make the consumers aware of the usage of the data. That is also one of the potential applications. That's a very interesting application, which I've one of the example which I have taken. So one of the application is this solar power forecasting. So it involves the knowledge of the sun's path, atmosphere conditions, scattering process, characteristics of a solar energy plant, closely linked to the problem of weather variable forecasting. So as one of you had also pointed out recently, you were asking a question that is there unstructured data in smart grid. So in fact, this is one of the example of unstructured data, wherein you are using the solar power forecasting, because weather forecasting is an unstructured data. So this data which you will get is that. So because you will get the radiation data from the satellite images, it will be used to develop the models, numerical models, cloud capacity, improved algorithms. So now we can forecast weather 4 hours ahead of time. Earlier we used to talk about long-term forecasting, long-term load forecasting, short-term load forecasting. Now we have now forecasting. We call it now forecasting because solar का आप बहुत अर्ली भी प्रिडिक्ट नहीं कर सकते. वेदर इज नॉट वेरी रिलायबल, राइट? ऑल्दो द weather department, they have got very advanced techniques now to predict it, but still sometimes it happens that you see that okay, today it is going to rain, but the whole day you see that there is a sun. So you can predict that thing many days ahead. So now the concept of now forecasting has also come into picture, wherein you predict the load or the weather for 3 to 4 hours ahead. Now, this is another very interesting application wherein the data analytics was used to make the consumers aware of the usage of their data. This is called as optimal individual energy use. So this report, as you could say, I will not call it bill, because in India we get energy bill, electricity bill. हमारे पास हमारे को क्या मिलता है? इलेक्ट्रिसिटी बिल मिलता है, जिसमें हमारे को लिखा होता है कि हमने कितने वो यूनिट्स कंज्यूम किए, हमारा कितना टैरिफ था, उसके हिसाब से बिल आ गया. दैट्स इट. बट इन यूएस दिस इज एन एक्चुअली एनर्जी home energy report of an actual customer by a company called PG&E. I think this is California based. I'm not very sure, but some company in US. So they have generated this home energy report of one of the customer, and what they have given is that this blue color bar chart you can see, they have told that you have consumed in 1 month. This is a bill of 1 month that you have consumed 4,191 units, which is as compared to, and they have compared that particular home with 10 homes within 6 miles that are of similar size. This is approximately 1200 square feet का घर है एक, तो उसके similar 10 homes within 6 miles के साथ उन्होंने compare किया. So this orange one is the efficient home, which they are calling, because they have used only 3,030 units, and similar homes they have used 5,352 units. So they are telling the customer that you have used 38% more energy than the efficient homes. And apart from the other homes, they have also compared the usage of that particular customer with his last 6 bills, because this is his current bill, July. And they have also compared, given a comparison of his usage for the last 6 months. And they said that, okay, this bill you have used 10-12% less energy than your last bill. Last bill se aapne 12% less energy. So imagine getting this kind of bill at your home, wherein you will be able to analyze, okay, last month हमारी इतनी हुई थी, इस बार ज़्यादा हो गई है, तो चलो कुछ saving करें. Apart from this, they have also given some suggestions that you should seal the leaky ducts, because the sensors, this information is being transmitted by the customer to the utility. So now they know that there is a loss of heat in that particular house due to the leaky ducts. You know, in US, they have these homes which are, what do you call it? वो पूरे वो होते हैं, बंद होते हैं, वहां पे पूरी हीटिंग होती है, कूलिंग होती है. सो सपोज यू हैव इवन अ स्मॉल लीक इन द डक्ट्स that causes huge amount of energy loss. So they are giving this suggestion to the customer that you should seal the leaky ducts, and by doing that you will be able to save up to $65 in a year. And of course and also they must be observing that उस बंदे की outdoor lights जो है ना वो ऑन ही रहती है, जो घर के बाहर कुछ पोर्च वगैरह होगा, दिन रात वो आउटडोर लाइट्स जो थी वो ऑन रहती होंगी. तो जिस उसकी वजह से भी उसका जो एनर्जी बिल है वो काफी हाई आ रहा था. So they have also given a suggestion that use motion detectors for your outdoor lights. आप मोशन डिटेक्टर्स लगाओ ताकि जब कोई आ रहा है, कोई कार आ रही है या पर्सन आ रहा है, उसी समय आपकी आउटडोर लाइट्स ऑन होनी चाहिए, उसके अलावा आपकी आउटडोर लाइट्स ऑन होनी ही नहीं चाहिए. एंड बाय डूइंग दिस यू विल बी सेविंग अप टू $35 per year. And also this is very interesting, and they have also given an suggestion that you upgrade to an efficient washing machine. बोलते हैं आप ना अपनी वॉशिंग मशीन चेंज करो, आपकी जो वॉशिंग मशीन है वो भी बहुत ज्यादा एनर्जी कंज्यूम कर रही है, उसमें बहुत ज्यादा लॉस हो रहा है इलेक्ट्रिसिटी का. एंड ये भी सजेस्ट कर रहे हैं कि जब नई लोगे ना, नया वॉशिंग लोगे, देन यू शुड लुक फॉर एन एनर्जी स्टार, most efficient clothes washer model to save on energy and water costs also. And by doing this you will be saving up to $35 per year. वो money के साथ में see they have related that आप अपना वॉशिंग मशीन कर लो चेंज, उससे आपके $35 बच जाएंगे. आप अपने घर के बाहर आउटडोर मोशन सेंसर लगा दो, उससे भी आपको इतने डॉलर्स बच जाएंगे. और आप अपने जो है लीकी डक्ट्स को भी सील कर दो, उससे भी बच जाएंगे. एंड ऑल्सो लास्ट 6 months का बाकी होम्स के साथ भी दे हैव गिवन अ कंपैरिजन दैट दीज ऑरेंज वंस, दीज आर द एफिशिएंट होम्स and this is the home particular consumer, and they have compared his electricity and gas consumption for the last 6 months also. So they have told him that you have used more electricity and gas than similar homes. वो जो बाकी के 10 homes within 6 miles है उनके साथ compare किया, and you have used $768 extra energy cost which you could have saved. So this, how did they arrive at this kind of conclusion? Because they have taken the data from the customer, they have analyzed that data, and it is not only analyzing, they are also giving the suggestion to the customer that you have used this much of extra energy cost, you are आप $768 जो है वो एक्स्ट्रा लास्ट के 6 months में खर्च कर रहे हो, आप ये चीजें करो, आपकी एनर्जी भी सेव हो जाएगी. So this is one of the application wherein the big data analytics was used to make the consumer or the customer aware of the electricity usage. So this is the name of that company, PGE, which has generated this home energy report. So we have come to the end of our session. What all we have discussed is that we have discussed the various challenges which are there in today's power system. Then we saw what is the definition of smart grid, infrastructure of the smart grid we have seen, but by the help of one animation we have seen the differences between conventional grid and the smart grid. Then we saw the various sources of the big data, why machine learning or artificial intelligence, deep learning, they are required for the analysis of this huge amount of data which is being generated called big data. Then what are the various characteristics of this big data? And finally, the potential applications of the big data analytics in smart grid. Now in the chat box, can anyone recall that what were these 4 characteristics of big data? 4 V's. Can anyone write? याद है आपको?
Ma'am, volume, veracity, variety, and these are the 4, no? Volume, veracity, variety, volume, veracity, and
very nice, very good. Thank you for the answer. At least that shows that you people are listening. That's very correct. So one is the volume, and a huge amount of data is being generated. Another is the velocity, the very fast rate by which the data is being transmitted. Third is the veracity, how much reliable the data is. And fourth one is volume, velocity, variety, the heterogeneous amount of data which is coming from the different sources, and they are in the different formats also. So again, as a data engineer, as a data analytics engineer, when we have the understanding the characteristics of the big data is also very important whenever you're working on that. So in the area of smart grid, then this is very important. Okay, so thank you so much from my side. That was all. And thank you so much for your patient listening.
Thank you, ma'am. I Dr. Neha Khurana, being the coordinator of this FDP, and I'm your student also, and we have been into the long collaboration, right, ma'am? And thank you very much for this session.
I have a long collaboration with Neha back date from, I think, 2005. It's been more than 20 years since we had this association. It's really nice, and Neha is a very good student of ours. It is always a pleasure to collaborate with you, Neha. Thank you so much.
Thank you so much, ma'am. And ये collaboration आगे भी चलता ही रहेगा. हम आपको हमेशा ही तंग करने वाले हैं ऐसे ही.
नहीं, मैं बिल्कुल मैं तंग होने के लिए तैयार हूँ. No worries, don't worry. So I've just shared my contact details in case anyone else is interested in making any type of collaboration with NITTTR Chandigarh. You are most welcome. And I'm always available on my email. I prefer email. So in case you want to get in touch, so you can just email me here. Thank you.
Yeah, I think जैसे यहाँ पर मैम बहुत अच्छी स्पीकर हैं, पार्टिसिपेंट्स भी बहुत अच्छे हैं, और सभी पार्टिसिपेंट्स को मैं बताना चाहूंगी NITTTR सेक्टर 26 चंडीगढ़ में मैम इज अ प्रोफेसर इन इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट, बताया है पहले भी, एंड बहुत ही एक्टिव रिसर्चर है मैडम, और आप उनसे बहुत अलग अलग तरह से थ्रू ICT के प्रोग्राम्स बहुत कराती है मैम. आप वो उनसे कोलैबोरेट हो सकते हैं फॉर कंडक्टिंग ICT प्रोग्राम्स. मैं मैम के बहुत प्रोग्राम्स करा चुकी हूँ अपने इंस्टीट्यूट में.
हाँ, because I have come to Neha's institute. इससे पहले भी I think एक बार आपने अटल का भी प्रोग्राम जब करवाया था. अटल का एक प्रोग्राम था ना जिसमें I had come there.
And
Neha, I would like to, if you permit, I would like to share one more information with the participants here, because I think they must be teachers. So अभी 26th of January को मेरा एक MOOCs का course, yes, of course, Puneet Chawla, again he is also one of my very good student, old student. Thank you so much for your kind words. So अभी 26 जनवरी को मेरा एक ना MOOCs का कोर्स जो है वो लॉन्च हो रहा है. That is on PLC and microcontrollers in Hindi language. So I will just share that details with all of you. And ये इंडिया का पहला टेक्निकल कोर्स है जो हिंदी लैंग्वेज में बनाया गया है. और उसका 3 रन इनफैक्ट लास्ट टू लास्ट ईयर ये फर्स्ट टाइम लॉन्च हुआ था. सो इट वाज वेरी पॉपुलर. आप लोग अपने स्टूडेंट्स को ये करवा सकते हो. AICTE अप्रूव्ड है और इसके 3 क्रेडिट्स हैं. तो स्टूडेंट्स दे कैन जस्ट अटेंड दिस कोर्स ऑनलाइन थ्रू MOOCs एंड देन दे कैन गिव एग्जाम एंड गेट 3 क्रेडिट्स. सो दैट विल लेसन अ बिट ऑफ योर बर्डन आल्सो. एंड बड़ा इंटरेस्टिंग है ये.
अभी NEP में जो 8th सेमेस्टर आ रहा है ना मैम, उसमें ये MOOC के कोर्सेज बहुत मतलब जरूरी है, और इलेक्ट्रिकल में हमने डाला भी है ये. So we will
Acha.
definitely get benefit from this. And as you are mentioning, it is AICT approved and has got 3 credits also. So it
Yeah,
is
yeah.
very much useful for all of us.
यस यस,
जो
ये
भी
मेरा
NI
ऑलरेडी जो है ना, ये
हो
इस
रहा है
बारी
ना,
फिफ्थ भी रन है इसका। मैं आपके साथ लिंक भी शेयर कर देती हूँ अभी।
हाँ जी,
तो
बिल्कुल
अभी ऑलरेडी इसकी एनरोलमेंट स्टार्ट हो चुकी है, 500
हम्म
समथिंग इसमें एनरोल हो गए हैं।
हम्म
So I will just share that link with you all, and even you can also enroll as a faculty in case you want to attend it, or
I
else
will
आप
run, I
अपने
will. हाँ,
students को करवा सकते हो। So I'm just sharing
definitely,
the link
definitely.
here.
एंड आपकी ईवी लैब भी आई हुई है मैम, सबको पार्टिसिपेंट्स को
हाँ,
पता होना चाहिए। निटर में मैम ने अभी अभी लॉन्च करी है ईवी लैब, बहुत अच्छी एस्टेब्लिश्ड है। आप लोग अपने बच्चों को लेके जाना चाहें तो जरूर लेके जा सकते हैं। एंड थैंक यू सो मच मैम फॉर योर वैल्यूएबल
thank
टाइम।
you.
थैंक
One
यू।
of the participant is asking my email ID, so I will just write here ritula@nittrtrchd.ac. ईवी के ऊपर तो ना मैंने इस बारी, अभी हमारा आजकल ओ प्लान बन रहा है, तो नेक्स्ट ओ प्लान में मैंने एक ईवी के ऊपर कॉन्टैक्ट मोड पे कोर्स भी रखा है। सो दोज हु वांट टू कम टू चंडीगढ़, यू आर मोस्ट वेलकम। अभी हमारा ओ प्लान अभी फाइनलाइज हो रहा है, उसका जो है वो नेट के ऊपर जब ओ प्लान आ जाएगा, अभी हम उसको टैग बोलते हैं, ट्रेनिंग एंड एकेडमिक कैलेंडर। सो प्लीज डू कम, बड़ा इंटरेस्टिंग रहता है वो, बिकॉज वो पूरा जो 5 days है ना, वो हम प्रैक्टिकल करवाते हैं। नेहा हैज ऑलरेडी सीन अवर ईवी लैब, सो वो पूरे जो प्रैक्टिकल्स है वो हैंड्स ऑन होते हैं। एंड अपार्ट फ्रॉम दैट, yeah, sure, Puneet. We will plan. Definitely, we will plan one FDP at your place also. So, ईवी के ऊपर इनफैक्ट आप लोग अपने स्टूडेंट्स, बिकॉज हमारी बहुत अच्छी इंफ्रास्ट्रक्चर डेवलप हुआ है ईवी के ऊपर, तो इन केस यू वांट टू ब्रिंग योर स्टूडेंट्स, यू कैन ब्रिंग देम फॉर 1 day or 2 day वर्कशॉप आल्सो। सो दैट प्रोविजन
डेफिनेटली मैम,
के आए थे
डेफिनेटली।
हमारे पास दिल्ली से स्टूडेंट्स।
ठीक है, बिल्कुल मैम। थैंक यू सो मच मैम फॉर योर वैल्यूएबल टाइम। हैंड ओवर टू यू जागृति।
Yes, ma'am. So thank you so much, ma'am. We really appreciate the depth of knowledge and clarity you brought to the session today. And the way you explained the concepts made the session extremely engaging and valuable for all of us. So thank you so much for such a wonderful session. So
थैंक यू,
now,
थैंक यू टू ऑल द
as a
पार्टिसिपेंट्स आल्सो फॉर बीइंग सो इंटरैक्टिव। मेरे को बहुत खुशी होती है, बिकॉज ऑनलाइन ना पढ़ाने में सबसे ज्यादा दिक्कत यही होती है, आई कैंट सी ऑल योर लवली फेसेस। सो कंप्यूटर के सामने बैठना पड़ता है, तो वो जो ये रिस्पॉन्सेज आते हैं ना, दे गिव अस ऑल्सो अ वेरी, मतलब मोटिवेशन मिलती है हमारे को भी।
तो अभी एक बार
yes,
सब ऋतुला मैम, आप भी और सभी पार्टिसिपेंट्स अपना वीडियो ऑन कर लें ताकि हम एक ग्रुप फोटो ले लें,
yes, ma'am.
है ना? यस, जागृति और भव्य,
Yes,
टेक अ
ma'am.
ग्रुप फोटोग्राफ। या
Done, ma'am.
ओके, थैंक यू भव्य।
Okay, so should I log off now?
या मैम, श्योर, थैंक यू सो मच।
Okay,
ऑल द पार्टिसिपेंट्स काइंडली फिल द फीडबैक फॉर्म।
So, okay, so now before moving ahead, I would like to inform to all the participants that the feedback form has been shared in the WhatsApp group. So kindly note that the attendance will be marked on the basis of that feedback form only. And the form will be closed shortly. So I request everyone to please fill it at the earliest. And our next session will be continued in 5 to 10 minutes. Thank you.
Good evening.
Good evening, sir.
Very good evening, Jagrati.
So now moving ahead with the program, it gives me great pleasure to introduce our next speaker, Dr. Ashish Srivastava, sir. He is currently serving as a skill professor of electrical engineering and dean, skill faculty of engineering and technology at Sri Vishwakarma Skill University, Haryana, and he completed his PhD from IIT Delhi. So with over 24 years of academic experience and more than 100 research publications, his expertise includes power electronics, power quality, renewable energy, and artificial intelligence. So today, sir will be delivering a talk on solar power forecasting using machine learning and deep learning approaches. So now I invite sir to kindly take over the session. Thank you, sir.
Thank you, Jagrati, for introducing myself to the audience. I'm sharing my slides. I think I'm audible to all.
Yes, sir, you are audible.
Yes, sir.
Fine. My slides are visible. Just please confirm whether my slides are visible.
No, sir, it's not visible yet.
Okay, just a minute. Is it visible now?
Yes, sir, it's visible now.
Okay, fine. Thank you for confirming. So yes, today is the topic for the discussion is the solar power forecasting using machine learning and the deep learning approach. So these two, machine learning and deep learning, is the buzzword these days and have been extensively used for forecasting whether it's a solar power, wind power. I don't know at what level I able to discuss with you. Jagrati, can you confirm that at what length I able to discuss? Or it was only the first slide?
Sir, you got disconnected at the very end, at the very starting.
From the starting itself. Okay. Chalo, then I need to start it again. I think there was some internet issue. So now the slides are visible. I'm just making in the PowerPoint mode.
Yes, sir, it is okay now.
Jagrati, you have to. It was the. Now again, I'm starting. Am I audible? Just for your confirmation.
Yes, sir, you're audible.
Okay, dear. Thank you. So yes, I'm starting again from fresh. So yes, if you look at the energy consumption scenario worldwide, it is increasing almost with the rate of 2% every 10 years, and now it is more and more because the now on the roads. Just for the information.
Excuse me, sir. Sir, it is breaking again.
ऐसा कर सकते हैं यदि इस बार ऐसा होता है तो विल डू दैट सर्टेनली ठीक है ओके डन डन Again, I'm sharing. Sorry for the interruption. I don't know what is happening with the internet. Is it visible, the slides?
Yes, sir, your screen is visible.
So this is some of the fossil fuel based power plants. They are perishable. That means they are depleting year by year. Maybe another 20 to 30 years, we would not find enough coal available in the earth crust. So certainly generation problem would persist. Global warming, we are already seeing that the temperature of during the summer is increasing due to the greenhouse gas emission. Then the air pollution is another issue, which is smog is another issue because of these coals, dust from the thermal power plant is there. Acid rain, which is another issue. Then soil pollution due to mining, and then dependency on the foreign country policy complications are also associated for the power transfer. This is the interest for everyone that yes, if you see in the left side bar chart, green color is talking about the growth of the solar power which is being utilized year by year. So if, as you can see, that from 2009 to 2018, the increase in the solar power production is around 20.66. This is what in case of India, the north part of India, especially Rajasthan, is having a lot of penetration of the solar power. So today's, and even wind is also increasing, as you can see from the left bar chart. So this is of our interest. So looking at this, certainly now we'll see why solar power is gaining momentum. Well, they are available in abundance worldwide. Secondly, they are available free of cost. Only there would be an installation cost, which is also decreasing on year-to-year basis, on a regular basis. So now coming to the problem and potential solution associated with solar power plant. Well, there are climate dependency. We mean that uncertainty due to the climate dependency. So obviously the power production. The solution would be you can have a battery storage, battery bank, and then another is you can have less unit commitment issue, so that you can, if you use a solar power. And another area for this potential solution would be the forecasting is the most cost effective and the promising way. That means you need to forecast that after 10 years, how much would be the solar power available, so that you can really see the demand requirement, power demand, and you can forecast accordingly. So this is our topic. I hope I am connected and I am audible to all.
Yes, sir, you're audible and connected.
Okay, fine. Thank you. Well, there are a lot of, whenever we start any research, well, obviously the literature review is the first task. So yes, there are around 38 references I have used for this particular presentation, where a lot of research has been gone for the solar power forecasting in the different countries. The first of the reference, which is of USA, and they are talking about the solar radiation. There are certain input parameter has to be selected once you apply the solar power forecasting. So most of the cases, the solar radiation, wind speed, W stand for wind speed. Then you have a T for temperature, H for humidity, and your P for pressure, and PR is for performance ratio. So these are the input variables which varies from analysis to analysis, from specific researcher groups who are working on this. So these all input variables, sometimes cloud cover, because in the countries like US, even Australia, the cloud cover is happening so frequently. So then that they used to take that as an input variable. So it depends how, sometimes sky image also can be taken as the input variable. And the target variable is solar power or solar radiation, mostly in the paper. And as you can see, time horizon, people have taken 24 hours, 5 minutes. So once you take within 15 days, that means 1 hour to, or certain minutes, 1 minute to a 15 day, then it will be considered as a short term. If you go beyond 15 days to 3 months, then it will go medium power forecasting. And if you go beyond 6 months, then it will go for a long-term forecasting. So there are different forecasting methods also being used. Regression, linear regression is normally being used, whether it's a Gaussian regression, linear regression, gradient boost regression. So there are many regression methods are available in your machine learning and deep learning as well. And then what are the statistical errors? That means which error, which parameter, performance parameter you are deciding. So these are the deciding factor once you are available with the data. So it is a RMSE is a root mean square error. MSE is your mean square error. Then you have a histogram method also is available. MBE is a mean bias error, mean absolute error, mean absolute percentage error, R square error. So these all are, if you can see, are the data parameters which you decide as a performance, and everywhere you can see in these 60-minute, 1 day. So these all are, all the work which has been done till date is mostly for the short-term solar power forecasting with a different statistical method, regression method which has been used. So if you use two mixed methods, whether support vector machine or least square support vector machine. So these all are the literature review I am just showing you that, but in all the cases it is short-term prediction which is being used, but anyone can go for a long-term and term prediction as well. So now going, what are the requirement for these solar power production? First, we have the classification of solar resource prediction. So you can have three major things in the solar resource prediction. One is forecast horizon, then the input data you need to decide, then the prediction technique, what prediction technique you are using. And mostly the work which is being reported is supervised learning. You can have a supervised, unsupervised, and the reinforcement learning. These are the three methods. So mostly supervised learning is being used, which is giving you more reliable, you can say, the output. This is what I was talking about. The short term, the outcome of forecasting work mostly is being focusing on short term, has the highest work is being done. Mid term, very little work has been done, and for the long term, very less work has been done. So normally, if you are taking a data from 1 minute to 15 days, then it comes under the category of short-term solar power forecasting. But yes, there is a scope. Major challenge for forecasting, whether it's a solar power or wind power, it's a data. You require a huge amount of data for training your network, whether it's a machine learning network or deep learning network, whether CNN, convolution neural network, RNN, or maybe LSTM by LSTM, GRU by GRU. You need to have a lot of data should be available. Now, what kind of data should be there? You should have data can be solar power, it can be solar radiation, it can be sun angle, it can be humidity, it can be cloud condition, it can be wind speed, it can be temperature. So that means you should have a lot of data should be available. It could be minute based, it could be hour based. So more is the data available to you, more it's better to train your network. So as you can see, this data is available: PV power, direct radiation, diffused radiation, reflected radiation, sun angle or sun height, temperature, wind speed. So as many data you have available, your network can be trained in much efficient manner, and it could give you a best prediction for given data. Now, this is what machine learning is talked about. It is supervised, unsupervised, and reinforcement learning. If you see supervised, it is being classified into classification based, regression based. In regression, you have a linear regression, neural network regression, support vector regression, decision tree, lasso regression. So that means a lot of options are available. And in case of a classification, then you have a naive based classifier, decision trees, support vector machine, random forest, k nearest neighbors. So that means lot many options are available for classifier as a classifier. Then in case of unsupervised, you can go for clustering, k means cluster. So Bayes clustering. Then you have a Gaussian mixture. So that means a lot of methods are available for clustering as well. And in case of reinforcement, we have a Q learning, R learning, and TD learning. So these all are possible methods. But yes, today we will be discussing more on the supervised learning. This is what the process is being adopted for solar power forecasting. This is the layout. You need a solar data set. It could be solar radiation, temperature, humidity, wind speed, precipitation. Then feature engineering is to be implemented, where you need to normalize the data, you need to standardize the data, you have to extrapolate, interpolate the data, so that, and you can remove the redundancy in the data. If there is a duplicacy, you should remove that particular redundancy as well. After that filtration, you have to apply this machine learning or deep learning model. Then you need to train your model, and then you need to check the performance. And this is a closed loop that you have to take from input to output, keep on running for certain number of steps depending upon the data available to you, so that you can check these performance error. These errors should be as minimum as possible, whether it's a MSE mean square error, MAE mean absolute error, root mean square error, RMSE, whether it's a mean absolute percentage error. So there are many R square error. There are many parameters or performance error parameter which has been ensure the performance of or the prediction of or training output of your particular network. This is what the benefits and uncertainties involved in solar power forecasting. One, obviously, benefits are you can improve the grid integration. You can always integrate your power with the grid. You can increase the efficiency of overall power system. You can reduce the power cost as well because it is available in the lesser costing. Improved energy management. You can manage the energy in a more appropriate manner. Maybe your microgrid or a smart grid can be a very good option. Then you can reduce the greenhouse gas emission, which can improve your environmental pollution as well. Well, uncertainty, there are so many uncertainties are also being involved, like weather forecast and uncertainty. You are not sure whether you will get a very good radiation today, how much irradiance you are getting on a day-to-day basis. Then whether you are able to measure those uncertainty, what will happen tomorrow, that is also not you can be very clear about it, even though meteorological department used to give you the prediction, but sometime it goes wrong. The uncertainty in the solar resource, that means how much strength solar would be available, we are not very sure about it. Then the model uncertainty, whatever the model you are using, maybe for more number of data the same model may not work, so you have to use different model depending upon the requirement. And then obviously uncertainty in the grid integration. Frequency is the major challenge whenever you integrate the solar power with the grid. The frequency is the major the parameter which need to be ensured. So today I'll be discussing about these 5 different topics. One is machine learning model for optimum selection of appropriate algorithm, then the hybrid machine learning model, then the deep learning model, then the hybrid model, and then the attention based model. These are the for a short term, medium, and the long term. For short term there are 3 options, top 3, and then remaining 2 will be your medium and the long term. So yes, the first one is the empirical evaluation of machine learning model for solar power forecasting. So what is the way we need to go? First, we need to see the literatures, what are the models are available, and then we need to select a proper machine learning model. As I said, there are many are available, and the k-fold, that means how many folds your cross validation is being done, that can be decided with the proper selection of the model, how many layers you are deciding. And the conventional, as well as what is the contribution in this particular work, that as compared to the conventional model, contemporary machine learning model are used for the solar power forecasting. It gives a clear insight for the k-fold cross validation, which are more grossly neglected in previous research work in the solar power forecasting. So that means, and then the 5 more number of benchmarking matrices you are keeping it will give you a more clear prediction. So here R square, MAE, RMSA, RMSLE, MAP, which is mean absolute percentage, all these 5 parameter has been taken for your solar power prediction. So first of all, let's understand what is the machine learning. Well, it is basically you can say computer program, which normally in terms of the Michel 1997, how it has defined. He has defined that a computer program set to learn from experience E with respect to some task of T and performance measure P. If its performance at task in T as measured by P improves with experience E. Basically what it talks about, first you have to take a data set. Data set should be as maximum as possible. Normally we talk about for machine learning and deep learning, data should be more than 1 lakh. If it is more than 1 lakh, your prediction, your training the network would be best. So first you need to collect the data. Then you have to select the regression, classification, or clustering, which is the task being involved. Then you have to select the accuracy, that means performance measure, how you are measuring the performance. Then you have to decide whether you are going with the supervised or unsupervised learning, that decide by your experience only. And then finally you make a generalized machine learning model, and with those model you see how well you are training your model. Then you can go for a hybrid modeling as well. So machine learning is normally going in 1 layer, deep learning going in the multiple layer. This is what the major difference. So you can say deep learning is subset of machine learning. This is how, if you input matrix you are giving, you are curve fitting, you are doing it, it is more inclined towards your straight line closer to your function. It says that you are fitting your curve in appropriate manner, you will get a better output. So your your function, what function you are defining, you are designing, that plays a major role. Similarly, it can be your random curved, you can say argument as well, and for which input matrix and output matrix you decide. When output is not for certain input, you have a certain output matrix. If you train that particular curve fitting your data, and you remove the redundancy in the data, and obviously skewness and kurtosis, if you remove, certainly it will fit into as per your requirement, that particular curve. So now what are the challenges for machine learning algorithm? First is the speed. That means how you are training your network, how you are testing your network. That means whatever your result should be there, it should be close to your training network. Then data requirement. You need, as I said, you need a huge data for training your network. Then the accuracy. Accuracy also will be tested, that how accurate, what are these performance parameter you have decided, how much lesser error should be there, it will be considered more accurate. And then the hyper parameter tuning, how you tune, because every layer, it's a weighted function. You need all neurons are being connected in the layer. How effectively you are, all the parameters you are tuning to get a desired. So this is what the machine learning, which is you can say algorithm, has to be expected from. So if you see the comparison of machine learning techniques or algorithm, there are, one is regression, is linear regression. It is very easy to implement, and training and testing is also fast. And what are the disadvantage? Only applicable for linear problems. So yes, mostly our problems are non-linear problems. So this does not fit into most of the cases. Input features should not be correlated. Sometimes input features cannot be correlated with the output feature. So it is very limited application. Going into K neural network, KNN, that is perform well for a small dimension data. So if your smaller data is there, you can certainly use KNN. Implementation is easy. Lesser number of hyperparameters are required. So less number of hyperparameter, you can do the tuning of this. But yes, the value of K is crucial. How you decide the K value, it is very crucial. How computational requirement is high for higher dimension. If your data is high, that will take a lot of time. So you need much more time for analyzing using KNN. Then you have a decision tree. Pre-processing of input data is not required, so you do not require pre-processing. That is the advantages. It gives explainable solution, so it can give the why this error is coming, how you can reduce the error. That kind of feature is available. It effectively addresses multi-collinearity problem. So if there are multi features are available, you need to very thin line difference between many parameters. It can give you, it can separate those functions as well. Overfits for higher number of trees. If you are taking more number of trees in decision tree, certainly it can sometimes overfits the data. Outliers affect the solution. That means once you are training your data, if it is making a out of your track or out of your expected value, if the cluster is going beyond your expected value, then those outliers will affect your solution. So that is an important parameter here. Complexity increases with the increase in number of trees. Certainly the system will become too complex if you are increasing the number of trees. Then we have a state vector regression. It has a high accuracy. Non-linear can be addressed with non-linear kernel. So this is what the advantage. It has a better, it performs better for high dimensional data as well. So this is the advantage with SVR. And slower training and testing. This is the disadvantage. Selecting appropriate kernel is tough. Sometimes how you decide the kernel, it is sometimes selection is difficult, and it is difficult to interpret as well. So this is also the one of the disadvantage with this. Then you have another is regularization, ridge, lasso, and elastic net. If you take, they are more efficient for high dimensional data. That means higher is the data, higher is the efficiency. Computationally efficient, it is more efficient once it has to be compute the higher amount of data. But yes, bias variation trade-off is tough. That means how you take the bias error once you take as a variance, then it is tough to decide about those dimension from 2 dimension to 3 dimension. So that is sometimes those reduction of dimensionality from normal data to 3D or 2D data is creating an issue. Random forest is again a very popular technique for machine learning. It efficiently handles high dimension data. It efficiently handles missing value as well. So redundancy can also be removed. New data does not affect the whole model. So if you are taking a new data after training, that does not impact. So that is the further advantage of it. Long training data is required. So that means you require a long data, means huge number of data, and high complexity for a longer tree and high computation. So these are the certain disadvantage. And then ensemble method is the another method in which ADA boost, XG boost, light GBN, these are coming. These also performance is good for high dimensional data. They also applicable for both linear and non-linear problems. They can less affected by noise and missing data. So this is also the plus point, but it has high complexity. Network becomes the hidden layers and multiple layers will be there. So it is a very complex network. Interpretation sometimes becomes tough and very sensitive to outliers. So any data which is beyond the boundary or beyond the expectation, they can create a lot of sensitivity to your prediction. So now what are the steps in building machine learning models? First, you need to decide the problem definition. Then you have to hypothesis generation is the next stage. Then data extraction or collection. Then data exploration and the transformation. This is to be done where missing value and outliers has to be removed. Then the modeling has to be done, which model you are taking, and then how you have model deployment and the implementation, how you are implementing, for which I said that you should know the Python language, and PyCaret is the open source platform where you can do all these, you can say, programming and all. So this is the heat map or normally correlation among input variables. On the x-axis, all the parameters data which you have, whether wind speed, temperature, sun height, reflected radiation, diffused radiation, direct radiation, PV power, and then on the x-axis again it is the same. So if you see diagonally, it will be a one value because it is always PV power with PV power will give you one. Similarly, the direct radiation with direct radiation will give you one, and rest other data would be less than one would be there. Closer to one give you a very good heat map, and it will give you a very good interrelation among all these data as well. So this is to be made first, and then how you do the data exploration and data cleaning, because once we have a huge data, first of all, exploration and cleaning is also important. So first is univariate analysis. You can have a multivariate or univariate. So univariate is one approach. Then you ensure missing value, if any, need to be extrapolated or intrapolated. Outliers, if any there, if suppose certain data which is looks to be going beyond your boundary, then those should be redundant, those should be removed. So redundancy has to be removed. Then collinearity, they should follow certain linear relationships and linearity among the data sets. So that should be there. This is the during the pre-process. Once the raw data is there, this is called the pre-process. Then after that, you need to do the data visualization. PCA is basically principal component analysis. These are the data which are basically used for the reduction technique. These all are PCA. TSNE is basically T-distributed stochastic your neighbor embedding, and UMAP in this data visualization, UMAP is considered to be the best. It is better than TSNE and PSA. This is known as uniform manifold approximation and projection. This give you all the you can say reduction technique is being implemented using UMAP, and it can give you the data converted into 2D or 3D with all reduction can be implemented. So this is what the UMAP is the best, which is being utilized in this. This is how you can implement the flowchart for the model development. First, you see there is during the starting, you should know the solar power data which you can load. Check for the missing value. If there is any missing value, you again take the mean, median, or mode of the missing data so that it can interpolate or extrapolate. Then again, you can go to the pre-processing of the data. And after that, if the mean or standard deviation is constant, then you can go to standardize the data, process the data. If it is not, you can normalize again. And then you can go to the process the data, divide the data in training and testing part. So you need to divide into two parts. One is training and then testing. Then at this stage, apply the machine learning model. Then train and evaluate the model. You need to train with the model, provide proper, you can say, weight to all the layers, all the weighted function, and then predict at the end. So this is normally a flow chart for any of your machine learning model to be developed. This is, you see the performance error of different class of machine learning. So these all are your machine learning models. These all are 5 performance parameter: mean absolute error, root mean square error, RMSE, R square error, RMSLE, then mean absolute percentage error. These all error has been calculated for those on your Python programming with the data sets which you have done. And in this, if these errors or the performance parameter, they are the minimum value, will be considered as the best. So here ET would be considered the best. If you see in all those models, these are giving the least value. So this is how you do the comparison. There are almost 15 these machine learning model have been done for this analysis. This is how train and test validation. As you can see, the blue dot is giving you the scores between 0.9 to 1 almost. So this is the training score, and the cross validation score, which is your test score, is also overlapping. So once this is being achieved, you can sure that there is hardly any error in your training and testing this particular validation curve for extra trees regressor. So once it is done absolutely matching with the least error, then that particular model is considered to be the best trained model for any of the data which you are giving as an input to that particular model. So as again, if you can see, you can do how many fold you are doing. You can do 5-fold, 10-fold, 15-fold. That means how many times you are closing the loop, how many times you are doing the cross validation. So you can see top 5 machine learning model: ET, GBR, Light GBM, Random Forest, and XGBoost. If you see mean standard deviation, this is ET is giving the best result as compared to any other parameter. So this is how the statistical error or your performance error giving you the least value will be considered the best one. Similarly, if you see the prediction of this particular PV power is given by the blue line, and with this shape, which is more identical to the shape, more nearer to the shape, is the black line, which is given by the ET. This ET line is perfectly matching with the shape. So this, which is the zoom portion of this particular area. So this shows that ET is giving a best projection, best prediction of the solar power. This is the result, one of the, you can say, graph of the residual error distribution, which again talks about the R square. If your trained R square value is 1 and your tested R square value is close to 1, you can say you have removed all the error. Your model has been trained to the best capacity, if that can done. So as you can see, training for R square, all these data in the blue color, if you see, they are also very close to this center line, which that means it is reaching out to the 1 value. That means your residual error distribution is perfectly mapped and R square is reaching close to 1. Once that will happen, your model can be considered as the best trained. So with this is first part of the, you can say, conclusion, that ensemble ML model also have the lowest mean and standard deviation in prediction error for 5 and 10-fold cross validation. Mean absolute error and root mean square error of ML models are varying from value of 1.89 into 10 to the power 5 watt to 1.79 watt. So ensemble models are performing better than machine learning methods. So in ensemble method, extra tree ET regression is outperforming the other machine learning model. That means in this particular work, as you can see, the lowest performance error values, whichever model you are achieved, will be considered as the best one. So in the second, you can say, work, I'll be covering the novel multi-stage framework for solar power forecasting. Again, the same 5 benchmark has been taken in this particular case. And now how this work has been done here in this particular case, 4 different location has been taken, and where the climatic conditions are different. One is Bucharest, which is in Romania, which is a continental climate condition. Their latitude and longitudes are given on the chart itself. Then we have taken Doha, which is in Qatar, which is a very dry climatic condition. Then Rieti is in Italy, which is having a temperate condition which varies very frequently, and Singapore is a tropical climate condition. So this particular work, different you can say location has been taken. For the same model, if it can fit into all those 4 locations, that could be considered as one of your best model, because it is trained for all different climatic conditions. So that was a challenge while doing this. So as you can see, solar power generating capacity of different locations. So in which Doha was highest because they have a high solar penetration, and Riti and Bucharest as almost, you can say they are not, that means Bucharest is on little lesser magnitude. Riti and Singapore almost have the same potential of the PV power. Now, how the model has been designed: first 5 parameter has been taken: solar power, temperature, wind speed, sun height, and irradiance. And then raw data has been taken. Fill the missing value. Missing places can be replaced with the mean, median, or mode of whole data set. So that means whenever data is missing, you take the mean, median, or mode of the whole data set, that can be replaced. Then the data scaling has to be done. That means to transform the data set on same scale. So that means standardization should be done, or normalization of the data should be done. Next is the problem identification. So in the next stage, you need to identify in this stage, input and output variables are decided. That means what are the output, what are your input parameters for solar power forecasting. Next is data is divided into 2 sets. One is training, one for testing part. So you need to train the network with this certain data set and testing with this some other data set. And then apply machine learning model on the training data. And then you see you can have ET regression, light GBM, then you have a EG boosting. So whichever method you are implementing, you can select those models, and then stacking of the top models. You can stack those models. You can apply the meta optimizer on the first stage prediction, and then you can do the solar power forecasting. You can also check the k-fold cross validation. That means how many times you are folding that particular data again and again. And then performance evaluation you can do with these 5 parameters which is being decided. So this is what the proposed model with 5 data set. And again, you run those models for all these different locations. As you can see, our proposed model is giving, there are 13 model which has been tested for this data. The first, our proposed model, which is a combination of your ET boost, is giving the best result for all these 6 parameters for Bucharest. Similarly, Cook distance outlier detection is also telling you that how much is the influence error. So if here it is 0.014 is nearly, so which is decided by the critical value is 4 upon m. So it should be as close to 0. If it is there, it will be considered as the best prediction from the Cook distance outlier detection. Then similarly, it has been done for Doha. Again, our proposed model performed better for all 5, you can say, or rather all 6 performance indices. Similarly, for Doha also, Cook distance outlier is 0.045 only. Otherwise, all data sets are very close to 0. And then similarly, it has been done for Singapore. Again, proposed model performed best because all these error indices are in the minimum value. And then similarly, the Cook distance is also quite 0.014 nearly. And then for Riti, also our proposed model performed best. So how you judge whether your model is best? These performance parameter should be minimal in comparison to the other methods which you have tested on your data set. Similarly, the Cook's distance outlier also 0.0078 in this case. So this is how you can do. So all these top 4 model has been also being compared, and which also gives you the best result for these. And this is how the learning curve for Singapore, that how you train the network. Though it is looking like a big difference, but this is not a big difference. Reason being, the values are 0.99970 and 0.99985. So at the 4th digit, there is a variation. So it's considered to be quite close to each other. So one is the training data through which you train the network. The other one is the testing data, which confirms that how you have trained your network. And this is what true versus predictive solar power. After your training, once you run the data, you will see both lines. There are 2 lines which are coincide each other. During the different hours of the Singapore, you see that both predicted value and the exact true value are perfectly matched with each other. So this is what the benefit of your prediction. Then another work which has been done. So till now, what we have done for the machine learning models. Now the autoencoder GRU, that is gated recurrent unit based deep learning approach, has been now implemented for short-term solar power prediction. So here, normally there are certain disadvantage with the machine learning. Machine learning models are basically a shallow network because they are single layer model. You cannot have a multi-layer is being incorporated. So it's a single step prediction is having a constraint for effective prediction. So you can, if you go for a deep learning, you can go for multi-step prediction, shows more robustness of the proposed model. So in this case, now we are comparing that what is the difference between machine learning and a deep learning. If you see machine learning, it's like input, there is a car, you extract certain features of the car, you do go for the classification, and then you can identify whether it's a car or whether it's not a car. This is the output. This is a single layer approach, you can say. But in case of deep learning, you have an input as a car, then you have a feature extraction and classification can be done with the multiple layers. Certain layers can be hidden or certain can be visual, but then it has been done in most deeper manner. So many layers will be there, and then you get a prediction, more accurate prediction. So deep learning is basically a subset, more deeper analysis of the data is being done. So that means you need more data, more weighted function by which you can do the deep learning. So this is how I think everyone would be knowing about the convolutional neural network, where you have an input value 1, 2, 3, it can go up to m. Then you have a weighted function for all those connections. Then finally they sum up. Then you have an output value, and then you can get the actual value with your modeling, what model you have been adopted. And this is what the basic neural network. There would be a layer 1, layer 2. There could be n number of layers could be there, which are connected with all the nodes, and implementing your these hidden nodes and weighted function with your desired input. For particular input, you can get the desired output. So you need to train the network similar manner, the manner you train the neural networks. Now, what are the different models are available in deep learning? It's a CNN, convolution neural network, RNN, recurrent neural network, then LSTM, long short-term memory. Then you have a GRU. Then you have double layer by LSTM and by GRU as well. So a certain comparison has been shown here that RNN, LSTM, and GRU. RNN have gradient vanishing problem. That means some the data which is on the more gradient side, so which prohibits network to learn in deeper network, and problem is mitigated. So this gradient problem is being mitigated, can be removed if you are using LSTM and GRU. So normally in LSTM, we have 3 gates: input, output, and forget gate, where you can use a multiple layer in the forget gate. And in GRU, you have a 2 layer, which is control gates, reset gate, and the your update gate, which can update your layers. So GRU generate less number of variables as compared to LSTM. So that's why GRU is sometimes being preferred. And LSTM is normally being adopted for longer sequences and longer data as compared to GRU. So once you have a more data, then LSTM is more being preferred as compared to GRU. This is normally their architecture, their mathematics, and then structure is being used. This is how deep learning is being done. You have an encoder layer, then you have a multiple hidden layers, then you have a decoder layer. In case of CNN, you can have an input matrix, then convolution layer, then you have a max pooling layer, kernel flattening of the data, and then you go to the predicted value. So this is how it is being done. So once you design the data, then you have to take the metrological parameters. That is, what is the latitude, longitude, elevation, slope, azimuthal angle, solar panel, then what are the losses, what is the power. So with those data at every instant, that what time interval you are taking the data, with that data you need to train. So this is what the AGRU based deep learning on the PyCaret it has been done. You have to train solar power train, which is to be trained, and then you have to test. A string has to be created. Then this particular has to train whole network. Then you have to initialize the weight and the biases. Then you have to train the AE with the SP train. So this is all programming which is to be done. And for the up to n number of layers, you need to go, and you have to, the purpose is to reduce or minimize the loss function. And this continuously you have to do it. And finally, you need to use certain dropout layers. If certain data has been dropped out, then you need to avoid the overfitting, you need to remove certain layers in that. And then finally, you need to finalize your whole program and with training the whole network. With the test graph and with your trained graph, both need to be match each other. Once that will happen, your network would consider to be a trained one. Again, once you run that particular system, so it has been done for 24 hours, 48 hours, and 360 hours, which is basically a 15 days, considering 24 hours in a day. So now again, these CNN LSTM, CNN GRU, CNN LSTM, GRU, and AGRU. Now, as you can see, AGRU is giving least value of error, whether mean square error, mean absolute error, R square error, whether it is a 24 hours or 48 hours or 360 hours. So that's why you can say that AGRU is performing better. This is how the graph is being drawn. As you can see, the AGRU is matching perfectly with the real power of the black color graph is overlapping. And compared to mean square error, it is the minimum error close to 0.00. That means 0.0012 it is coming, the flatter line. So that way you can say that AGRU has performed better for 100 iteration it has been done. So with this, you can say that for your MSc, MAE or R square, your this AGRU has performed better as compared to your GRU or any other model. So this is one of the work which has been done. Now for the deep learning model, another hybrid model which is called CNN with bi-LSTM. Bi means double layer LSTM. So this also has been explored with the data where at the same location but different longitude at constant latitude, this has been implemented. So latitude is same but longitude is different. So in the same city, if latitude is same, you are moving to the location, longitude will be different, elevations are different, optimum slopes degrees are different, azimuthal angles are different, then maximum solar radiations are different, temperature is different. And for 1st January 2014 to 31st December 2015, the data has been collected, has been taken from the NASA website, and that data has been again used, and then your data processing, redundancy, everything has been removed after the heat map. Now this model has been proposed where you have a solar radiation database, normalization and reshaping of the multi-layer CNN layer it has to pass through, flattening of the data is being done. Then double layer, bi-LSTM means there would be forward layer and a backward layer. So then this has been passed through this bi-LSTM, and then at the dense output, you have taken finally the output after removing the dropouts of the undesired data, you get the output. So this is the proposed model which has been implemented in this case. This is how the programming has been done for this CNN bi-LSTM network. And this is the model summary. And now you see the prediction. Your latitude, same latitude, but longitude is changing. And as you can see in this bar graph, 100 iteration has been done. CNN bi-LSTM, which is the color, or you can say the rightmost color is pinkish, light pinkish color, is giving a lesser height. That means they have a mean square error is much minimum as compared to the other bar chart. Similarly, mean absolute error, MAE, is also lesser for CNN bi-LSTM. And then you compare for the other location also, for R square error, for standard deviation, for the skew, for kurtosis, for MSc, MAE. If you see, your CNN bi-LSTM is giving the least value. And once this is giving you the least value, suddenly you can say that this particular model is giving the best result in terms of the predicting the solar power for same latitude but the different longitude. Similarly, it has been error minimization has been tested for 100 iteration by all the 5 methods, and again CNN bi-LSTM was considered the best in those MAE and MSQE. And in this 5 performance error also, CNN bi-LSTM is coming the lowest one. So this is completely, you can say, outplayed other 5 parameter in terms of the error, although the difference is much lesser. But once you make the comparison, obviously the best one would be which is having the least value. So in this work, you can say CNN bi-LSTM based hybrid DL method is proposed for. This is midterm solar radiation prediction. So it performs better, outperform other DL method in both univariate and multivariate prediction. in terms of loss function, MAE, with giving less distorted distribution in prediction. So you can say that you did 5 comparison, and this hybrid model is deep learning model is giving the best result. Now, in the last category, the potential net, which is a multi-directed attention-based solar power forecasting method, has also been tested. It is a very complex, you can say, network which has been being created through the programming in on the PyCaret on Python platform, where hyperparameters have been earlier work has been neglected. This has been included in with multi-layers, bidirectional LSTM layers. It has been included. So here you can say that the data from the Australia Desert Park has been taken, where this power plant has the capacity of 1058.4 kilowatt on polocrystalline panel, where data has been come in the form of cluster in the images. These data set has approximately 4 lakh data points. So you can see, this is what I was telling, that you need a lot of data. Minimum 1 lakh and above would be there. It will give you a very good prediction. If your data is lesser, your network may not be trained to the best of their prediction value. So with 12 feature variables have been taken from different sensors on 5-minute resolution, which create the latent space for DL model for training and testing. So first, as I said, now concatenation and attention. Concatenation basically is known as you can 2 strings or more than 2 strings can be joined together. So if you parallel string combination, if you do it, you can do it with the concatenation. And in case of attention, you can fix the parameter which are more important for you. So you can target specific data if you are doing the attention one. So in BiLSTM is doing the particular data to be focused upon, where you see what is the features as extracted. And concatenation, we are doing that data should be filtered out with the parallel processing, and it could be clubbed at the last stage after filtration. This is how algorithm has been done. In this particular case, first LSTM layers are the hidden layers. CNN layer first is being used for the loss function, which reduce the loss. And finally, at the end, Bayesian optimization has been used. So it is a full hybrid model, which has been used here for the prediction, which is known as the proposed differential net. And once you run this particular model, now you again see the minimal value of mean square error at the start, at the end. It is during the starting, at the end of the iteration. Similarly, it is at the starting of MAE error, mean absolute error is also minimal during the starting and during the end. So you can say that with the hybrid parallel layers of CNN BiLSTM, you always achieve a much lesser value of mean square error or mean absolute error at the starting, at the end. So this is some certain hybrid parameters which has been seen as a search space as the losses, that how it has been generated, strings has been generated. And this is what error and predicted values of the deep learning model. So as you can see, this is the green portion is talking about MAE, and MSE is a blue portion. In blue, you would not find enough data. In green, you can see that MAE is much lesser as compared to others. Similarly, on the next chart also, the production or the power prediction, you can say, is perfectly mapped for your differential net as compared to the other one. Although difference looks to be minimal, but once you zoom this, because then you can able to see the difference in this case. Similarly, so now with this, I'll come to the end of the presentation. I just conclude finally that attention model effectively tap the long-term temporal dependency by tapping the information of the hidden state weights. So here you can have an option that you can, in deep learning, you can always hidden layers, multiple layers can be generated. So context vector provide more attention to the relevant features by adding more weight. The proposed net, which has been proposed with LSTM, CNN, BiLSTM, and Bayesian optimization, performs the best hybrid deep learning model with 2.34% and 2.75% in terms of MSE and MAE. The outcome shows the differential net based forecasting method has higher efficiency than any other deep learning model, and it reduces the cost around 0.329% with its nearest competitor model, which is attention based CNN LSTM. And the social acceptability of the solar power plant is significantly high as compared to other renewable energy generating power plants, because land requirement is low for the solar power plants, and also the direct job generating potential is quite high. So these are the few references which I have already in the beginning. I have mentioned in the first name of the author that what they have used and what are the different you can say parameter they have selected, and what are the different methods they have used, and what are the error indices they have selected. So these are the few 38 references I have gone through. So with this, I'll come to the end of this presentation. I would happy to answer your queries if any. Although it is a little complex topic, it's more should be a hands-on one, because maybe PyCaret or the Python programming, if you are not aware, it would be difficult to understand. But it has an exhaustive use in electrical domain. So with this, I come to the end of the presentation. Please ask if you have any query. Any query, any questions?
So good evening, Ashish sir. Dr. Neha Khurana here.
Good evening, madam. Good evening.
कैसे हैं? ठीक हैं सर आप?
Yeah, बिल्कुल ठीक ठाक, madam.
Thank you for sparing your time.
Thank you, madam.
Conducting the session. And now all the participants kindly fill your forms, feedback form, and put on your video so that group photo can be clicked. Participants. सर आप चाहे प्रेजेंटेशन अपना वो बंद कर दीजिए अभी हम
Okay,
आप
yes,
वीडियो काइंडली पुट ऑन योर वीडियो सो दैट वी कैन टेक अ
sure,
photo.
sure, sure.
Now over to you, Jagriti.
Yes, ma'am. Okay, so on behalf of the organizing team, I sincerely thank Sir for such an insightful session today, and your knowledge and perspectives were truly valuable. Also, thanks to all the participants for your active involvement and enthusiasm. It made today's session meaningful. We look forward to seeing you tomorrow on time for the next session. And a reminder that attendance is mandatory and will be marked through the feedback form shared during each session. Thank you once again and have a great day ahead. Thank you, sir.
Thank you, Neha madam. Thank you for giving me the
Thank you, sir.
opportunity. Thank you.